Hi guys, this is Mrs. Allison. Today we are going to look at linear inequalities. So an inequality or a linear inequality really looks very similar to a line. The difference is that it has an inequality symbol in it. So if we want to find a solution to an inequality, it looks a little different than it would if it was an equation, because if it's an equation, the solutions are every point on the line. Well, with an inequality, it's going to be a solution region, and we have to see if the solution lies in that region. But the same thing is true. To check to see if it's a solution means it makes the equation or the statement true. So let's look at an example. Let's look at the example, y is greater than x minus 3. Okay, so that's an inequality, a linear inequality. And you may be asked, is the ordered pair 1, 2 a solution? Well, to determine if it's a solution, I'm going to do much the same thing I would have done if it was an equation. I'm going to test the point. So I'm going to substitute x in for x and y in for y. So in this problem, I would have 2 is greater than x minus 3. So is this a true statement? Is 2 greater than negative 2? Well, yeah, 2 is greater than negative 2, so the ordered pair 1, 2 is a solution. Okay, well, let's look at another one. Is negative 2, negative 5 a solution? Pause, try it, see what you come up with. All right, so this is x and this is y. Let's make a substitution. Is negative 5 greater than negative 2 minus 3? So simplifying, is negative 5 greater than negative 5? The problem with this one is the answer is no. Negative 5 is not greater than negative 5. So negative 5 is equal to negative 5. So if that had been an equal sign as well, we could say yes, but it is not. So that's how we determine if something's a solution. So what we're going to do to be able to graph this, to be able to find our solution set, is we're going to graph. It's the only way we can really solve linear inequalities, or the best way. So the first thing that we want to do is we want to get it into, get it into a graphable form. Okay, what do I mean by a graphable form? Well, I mean points or slope-intercept form, y equals mx plus b. Or point slope form, y minus y1 equals m times x minus x1. Or x equals 3. Or, x equals any number, doesn't have to be 3. Or y equals any number. Those are all my graphable forms that I have right now. Okay, so once it's in a graphable form, we are going to then graph it like normal. And what I mean by graph it like normal, just like we would if it was an equation. We're going to graph it like normal. Then the next two parts are the two parts that are going to be a little bit different than just graphing equations of the line. And the first thing that we need to consider is the line going to be dotted? Some people say dashed. Dashed or dotted means the same thing, or solid. So you've got to ask yourself, is it going to be dotted or is it going to be solid? The way we determine that is based off of what inequality sign is there. If it's going to be dotted, then it's going to be greater than or less than or not equal to. If it's going to be solid, it's going to be greater than or equal to or less than or equal to. or just equal to, because that is what we're used to graphing, a solid line. Okay, well then what we're going to do is we are going to look at shading. So we call this shading our solution set. And the best way to determine shading is by picking a point. And I'll look at what that looks like in just a second. So let's look at an example. Let's look at the example. Let's graph y is less than negative 4x minus 1. So first, is this in a graphable form? Yes, this is in a graphable form. So the form that I can graph this in, this is slope-intercept. So I'm going to start at my y-intercept of negative 1. And I'm going to count down 4 over 1. Down 4 over 1. Or up 4 over 1, the other direction. Okay. Now, the next thing I need to determine is if this is going to be a dotted or a solid line. Well, I'm going to determine that based on the fact that this is in a less than sign. So this is going to be a dotted line. Now, the way that I graph a dotted line is I just draw it like this. You can see why people might call it dashed. Now, the next part that I need to do is shade my solution set. Well, here's what that looks like. A solution set is, see how the line divides the graph into two parts? My solutions are either going to be all of this part or all of this part. So the best way to tell what my solution set is going to be is to pick a random point. If I can pick 0, 0, I will. But because this line goes very close to 0, 0, I'm not going to pick that this time. So let's pick a different point. Let's pick the point, let's call that point 3, 1. So we're going to pick the ordered pair 3, 1 to test. To do that, what I'm going to do is I'm going to substitute in 3 for x and 1 for y. So in my inequality, I would have, y, which is 1, is less than negative 4 times my x value, which is 3, minus 1. Okay, and now I'm going to do the math for that. Is 1 less than negative 12 minus 1? Is 1 less than negative 13? No, 1's not less than negative 13. That's not a true statement. So here's what that tells me. Is the side that 3, 1 is on, this side over here, is not where my solutions are. So it means that the solutions that I want are all on the other side. So I am going to shade the other side, and that represents my solution set. Now, I am going to ask you to tell me each time a possible solution. So if I want to know a possible solution, it means I want you to pick any point in that shaded region, because any of those is a possible solution. So let's say I pick the ordered pair negative 4, negative 2. I could also prove that this works as a solution by plugging that into my inequality. Is negative 2 less than negative 4 times negative 4 minus 1? Is negative 2 less than 16 minus 1? Well, yeah, negative 2 is less than 15. That's a true statement. So I know it is a solution. All right, I would like you to try one. Try this equation. Let's graph y is greater than 1/2 x plus 3. Let's do y is greater than or equal to. Y is greater than or equal to 1/2 x plus 3. Hit pause and try this problem. All right, hopefully you had a chance to go through this. So first, we're going to start at positive 3, and we're going to go up 1 over 2 and down 1 over 2. And then I know that this, because it's an equal to, needs to be a solid line. So I'm going to graph a solid line through those points. I also know that because that line there divides my graph into two regions, I have the possibility of this shaded region, or I have the possibility of this shaded region. And it's all going to be based on the point I pick. So let's pick the point. You know what's going to be easy to pick now? 0, 0. So let's pick the point 0, 0. And I'm going to test that in my equation. Is 0 greater than or equal to 1/2 times 0 plus 3? Is this a true statement? Is 0 greater than or equal to 0 plus 3? Is 0 greater than or equal to 3? Well, no, 0 is not greater than 3. So I know that my solution region is the side that's 0, 0, not this side, but the other side. So my solution region is up here. So let's pick a possible solution. If I pick a possible solution, it's any point in the shaded region. So I could pick the point 8, 9. 8, 9 is a possible solution. Let's look at one more example that can be a little bit funky. Let's do x is greater than -2. X is greater than -2. Is this in a graphable form? Yeah, it's a constant. So what kind of line is x equals? It's a vertical line. It's a vertical line at -2. And so if I go and sketch a graph of this before I actually do, let's determine, is this going to be dotted or solid? Well, based on that inequality sign, this is going to be dotted. So I'm going to have a dotted line at -2. So I'm just going to go ahead and draw that in. So that means that I have two regions for my solution. And you can see these ones pretty easy. Either all my solutions are going to be to the right of the line in this case, or all of my solutions are going to be to the left of the line. Okay, so to determine this, let's pick a point. So let's pick the point, again, I'm probably going to stick with 0, 0, just because it's a nice, easy point. I can see it. I know it's on one side of the line. And if we know that this is x and this is y, well, what do I notice about my equation? I only have an x value. So x is 0 is greater than -2. I just need to know if this is a true statement. This is a true statement. So because this is true, my solution are on the side with 0, 0. And I don't even have to work very hard to figure out a possible solution, because I know one of my possible solutions is 0, 0. It's the one that works. But any point in here is a possible solution. So is the point 6, 5. So is the point 1, -10. So is the point -1, -5. All of these are possible solutions because they all fall within that solution region. All right, you guys, so that's the idea of linear inequalities. The next video we look at, we're going to extend it to a system of linear inequalities. So we'll see you soon.